Good morning children. In today's class we are going to learn a variety of differentiation techniques. How to differentiate with just application of formula. In the previous class we learned how to find the derivative using first principles. In today's class, the formula that we have already derived using first principles is listed. We just learn the formula by heart and we apply in the problems. X power n, the formula nx power n minus 1. E power x will become e power x. Log x base e becomes 1 by x. Constant becomes 0. Applying this x power n for x power 1, 2, 3 we have listed. It is good that we remember these while doing problems. X becomes 1, x square becomes 2x, x cube becomes 3x square. By putting 1, 2, 3 for n we derive this. Let us remember, constant becomes 0, x becomes 1, x square becomes 2x, x cube becomes 3x square. 1 by x and root x. For 1 by x, put n equals minus 1 and we derive minus 1 by x square. For root x, we put n is half here and we simplify to get 1 by 2 root x. So remember, 1 by x becomes minus 1 by x square and root x becomes 1 by 2 root x. Sin x becomes cos x becomes minus sin x. Tan x becomes secant square x, cot x becomes minus cosecant square x. Secant x becomes secant x into tan x, cosecant x becomes minus cosecant x into cot x. You have e power x which becomes e power x. Other than e, any other number a which is greater than 0 comes. A power x will become a power x log a base e. You have product and quotient rule. When it is the product or quotient, we'll see to it in the problems to come. Let us remember this formula to apply in exercise problems. Exercise 5.5, question number 1. Differentiate with respect to x. Given a question, let us take f of x is equal to 3x power 4 minus 2x cube plus x plus 8. F dash of x is 3 into. What is x power formula? X power n becomes, we put the whole dash for derivative, n x power n minus 1. Applying 4x power 4 minus 1 minus 2 into x power 3. Apply the formula 3x power 3 minus 1 plus x will become 1 as we have done here plus constant will become 0. It is 12 x power 4 minus 1. 2 3s are 6 x power 2 plus 1. So this we call f dash of x. The same problem if I take the given function as y. As I differentiate, I will call dy by dx. Second subdivision, 5 by x power 4 minus 2 by x cube plus 5 by x. The given question, let us take as f of x. Denominator x power 4 goes to the numerator as x power minus 4 minus 2. X power 3 goes to the numerator as x power minus 3 plus 5 by x. I will write 5 into 1 by x. We know the formula for 1 by x, that is minus 1 by x squared. So we can directly apply whenever 1 by x comes. The remaining we shall apply x power n formula. we write differentiating with respect to x, f of x becomes f dash of x, that is 5 into x power minus 4. Apply the formula. Minus 4 x power n minus 1. Minus 4 minus 1. Keep minus the coefficients as it is. X power minus 3. Apply the formula. Minus 3 x power minus 3 minus 1 plus 5 into 1 by x. Let me remember the formula, minus 1 by x square. As we simplify, f dash of x is equal to minus 20 x power minus 4 minus 1 minus 5 minus into minus plus 2 3s are 6 x power minus 4 plus into minus minus 5 by x square. We write one more step by bringing the negative power denominator. Minus 20 by x power 5 plus 6 by x power 4 minus 5 by x square, and that is the answer. Third subdivision, as we see the problem, here we had taken f of x. Let us do one with y. The given question I can consider as y. Root x. I know the direct formula, that is 1 by 2 root x. 1 by cube root of x. Cube root tells me power 1 by 3. Taken to the numerator, power minus 1 by 3. Apply this formula. Minus 1 by 3 x power minus 1 by 3 minus 1. The third one, e power x. We know the derivative e power x itself. Simplifying. So let us remember both the notations. If I consider f of x, I will write f dash of x when I differentiate. If I consider y, I will write dy by dx. 1 by 2 root x minus 1 by 3 x power minus 1 minus 3. Minus 1 minus 3 is minus 4 by 3 plus e power x. Bringing it to the denominator whenever the power is negative. 1 by 2 root x minus 1 by 3 x power 4 by 3 plus e power x, and that is the answer. Subdivision 4, 3 plus 2x minus x squared by x. When I consider y, the denominator is having single term. Remember, you can split it. Whenever the denominator is a single term, split it. So first term by denominator plus second term by denominator minus third term by denominator. That is 3 by x. X cancels 2. X squared by x is x. When I differentiate with respect to x, y becomes dy by dx. 3 by x, 3 into 1 by x. Remember the formula, minus 1 by x squared. Plus 2 is a constant which becomes 0. X becomes 1. When you apply n is 1, x becomes 1. So my answer, dy by dx equals minus 3 by x squared minus 1. Fifth subdivision, x cube e power x. When you consider y is x cube e power x, there are two terms in product. So what is the formula? Treat uv the whole dash product of two terms. Keep the first term. Differentiate the second term. Plus keep the second term. Differentiate the first term. So how will I write it? Keep x cube. Differentiate e power x. Plus keep e power x. Differentiate x cube. So x cube into e power x derivative e power x plus e power x into x cube derivative, apply the formula 3x power 3 minus 1. In both the terms, e power x common. Take it out. We are left with x cube plus 3x square, and that is the final answer. So this we call product rule. Whenever you have two terms in product, keep the first term, differentiate the second term, plus keep the second term, differentiate the first term. So this we call u into v. U is first term, v is second term. Dash tells me differentiating. So keep u, vu differentiate, plus keep v, uv differentiate, and we simplify the answer. Sixth subdivision. X square minus 3x plus 2 into x plus 1. The same pattern, again it is in product. So let us remember, u into v, the whole dash is uv dash plus vu dash. Y, when I differentiate with respect to x, I will write dy by dx. Keep the first term, x square minus 3x plus 2 into, differentiate the second term, plus keep the second term, differentiate the first term. It becomes x square minus 3x plus 2 into, x becomes 1, constant becomes 0. Let us remember the formula list. X plus 1 into, x square becomes 2x minus 3, x becomes 1, constant becomes 0. Just multiply 1 into, so it is the same term, plus x into 2x, x into 3, 1 into 2x, 1 into 3. Simplifying, 2x square plus x square, 3x square, minus 3x minus 3x minus 6x plus 2x minus 4x. 2 minus 3 is minus 1, and this is the answer for dy by dx. The next subdivision, x power 4 minus 3 sin x plus cos x. Considering y as the given function, differentiating with respect to x, let us recall the formula. X power 4, apply x power n formula. 4 x power 4 minus 1 minus 3 as it is. Sin x becomes cos x. Cos x becomes minus sin x. So the answer, 4x cube minus 3 cos x minus sin x. So just a two-line answer provided. You remember the formula for x power n derivative, nx power n minus 1, and sin x becomes cos x becomes minus sin x whenever we differentiate. Eighth subdivision, root x plus 1 by root x the whole square. Consider y as the function root x plus 1 by root x the whole square. Expanding, a square plus b square plus 2ab. As we simplify, root x square is x. 1 by root x square is 1 by x plus root x cancels. We are left with 2, and this is y. Differentiating with respect to x, y becomes dy by dx. X becomes 1, 1 by x becomes minus 1 by x squared, constant becomes 0. So what is the answer? Dy by dx is 1 minus 1 by x squared. Question number 3, subsection 1, x sin x. Whatever is the question given, consider it as y. Differentiating with respect to x, y will become dy by dx. There are two terms, keep the first term, differentiate the second term, plus keep the second term, differentiate the first term. X into sin x will become cos x, plus sin x into x will become 1 just by using the formula. So remember the formula and the problems are just in 2 steps. Second subdivision, e power x sin x. Again there are 2 terms. Differentiating with respect to x, y will become dy by dx. Keep e power x, differentiate sin x, plus keep sin x, differentiate e power x. The next step, dy by dx equals to e power x into sin x derivative cos x plus sin x into e power x derivative e power x. In both the terms, e power x is common. So take e power x out. It is cos x plus sin x, and that is the answer. Third subdivision, e power x into x plus log x. Differentiating with respect to x, y will become dy by dx. There are 2 terms. Keep the first term, differentiate the second term, plus keep the second term, differentiate the first term. Keep e power x, differentiate x plus log x, plus keep x plus log x, differentiate e power x. dy by dx equals to e power x into x will become 1, log x will become 1 by x, plus x plus log x into e power x will become e power x. In both the terms, e power x is common. As we take e power x common, it is 1 plus 1 by x plus log x, and that is the answer. Subdivision 4, y is sin x into cos x. Again there are 2 terms. Keep the first term, differentiate the second term, plus keep the second term, differentiate the first term. Sin x into cos x will become minus sin x, plus cos x into sin x will become cos x. It is minus sin square x plus cos square x, or we can simplify this as cos 2x. This is first method. The same problem we can do it in second method using trigonometry formula in the first step. Y equals sin x cos x can be rewritten as sin 2x by 2. Remember, sin 2x is 2 sin x cos x. So y is sin 2x by 2. Differentiating with respect to x, y will become dy by dx. 1 by 2 as it is. Sin will become cos 2x. Whenever 2x is coming into 2, 2 and 2 cancels, giving us the answer cos 2x. So we use chain rule. If it is only sin x, it will become cos x. If it is sin 2x, it will become cos 2x. 2x will become into 2. So either you do with trigonometry formula applied in the first step or trigonometry formula applied in the last step.